If you ever download a scientific tool and then you had to run commands like make and CMake or qmake, all of these seem a bit confusing to you? No worries, in this video we will walk through all of these commands and understand why we need them. So let's start with a simple question. Why developers, when they write software in languages like C or C++, they don't just share a program that you can already run and execute? The answer is that different computers actually are different. So a program compiled in one machine may not work on another one because of differences in operating systems, processors, architectures, libraries, and so many other things. So instead, developers often share the source code, which is something that we as humans we can read, and then we let each computer compile it themselves. So then how do we go from the source code to a program that we can actually run? So the process looks something like this. So we have the source code that we just downloaded from the internet, for example, and then we have to run CMake or qmake, and then after this make, and then we finally have an executable file that we can just run. A simple way to think about this is with cooking. The source code is like a recipe and all the ingredients that you need to do this recipe. Then CMake reads that recipe and prepares the cooking plan based on the kitchen that you actually have, so it adapts based on what you have. Then Make follows that plan and tells the chef what needs to be cooked. The compiler is exactly this chef who actually cooks the meal and depends on exactly your kitchen, your chef, yourself. Then the executable is just the dish that the chef just made. Okay, so let's see this in more detail. Imagine that you just download a project and it might look something like this. You have your project folder, and then inside you might have different folders. One of them might be SRC, which is the source folder. This folder contains the source code, so all the files .c or .cpp, depending on if you're coding in C or C++, respectively, and they contain all the scripts that your code will actually run. So it contains all the conditions, all the ifs, all the things that you want your program to do. And then you might have a folder called include, which usually contains the header files, the .h, um, which have the declarations of all the functions and all the variables. You also might not have any of these folders, and you might have all the files just all together lying around inside the main project folder. But then you definitely should have something that is called CMake lists.txt. This file describes the project. It tells the building system which source files belong to the project, which external libraries are needed, and which compiler options should be used. So to make the compilation and to be easier not to have all the files lying around, we usually do is to create a folder called build. So you just run the command mkdir build to create a new folder. And then you go inside that folder with cd build. And then finally run the command cmake. And then you add the two dots because you need to specify where the CMake will find this file CMake lists because it needs it to run this thing. So the CMake itself is not already compiling the program. It just reads this file, the CMake lists, and examines your computer, and it checks which compiler is available, which version it is, and where the libraries are installed. Using this information, the CMake will actually generate build instructions adapted specifically to your machine. One of the main files CMake creates is this file called makefile. So after running CMake, your project will have makefile inside the build folder and something also called cmake cache.txt. Notice that we still don't have an executable at this point. So this is just possible when you run make. it's also where some people get confused. The make itself is not compiling the project. It's almost compiling the project. Make will just build some instructions like saying compile the file called main.cpp, the file named math.cpp, link everything together, and then we'll call the compiler to actually do it. So when you call make, it's already actually calling the compiler, even though it's not make itself that is doing the compilation. So after the compiler do its thing, you'll end up with an executable file in this folder. You may have also heard about qmake. Qmake is similar to CMake, but was designed more specifically to take care of applications of graphical applications. There, instead of a CMake list.txt file, you actually will read a file that ends in .pro. But the idea is basically the same. Finally, do you need to run all these commands all the time? Usually, no. You do this once and you have this executable file. Then, if you are editing your application and you're editing the .cpp files, you just need to run make again so that he understands that you change those files because the make file already exists. However, if you change the project yourself, if you add new files or if you change the name of the files, you have to update the CMake lists so that your program knows that needs to consider those files as well. So then you need to run again CMake and then make. So to better understand these two commands, we are going to do some practice. Okay, so I'm already in my Linux machine where I've downloaded an application in C++ that is very basic and the objective is just to write hello world. Okay, so we are going to use it. So first we are going to open the terminal and we are going to go inside this folder. We can see that inside the folder we have already a file named CMake lists. .txt and then the other files. So the first thing we are going to do is indeed to create a folder called build just so that everything goes inside that folder and doesn't disturb the rest. So we'll do mkdir build and now we are going to go inside the build. So obviously the folder is empty. So the first thing that we are going to do is to run the CMake command and we'll add the two dots as the CMake list file is on the folder above. So just one back. And we can see that CMake is done already a lot of things and it finished with successfully. So we can see again now in the folder and we have files here already. We have something called CMake cache, CMake file, CMake install, and all these things that were not there before. So now the next step is to do make. So now make is doing the final step and then using the compiler to actually compile the program into something that we can use now. So if we do again ls to see what's happening in this folder, we see that we already have an executable file called CMake hello world. So we can execute it and see what happens, and we see that it has been written hello world. Okay, so I'm already in my Linux machine. Okay, now imagine that you are working in this application and you actually change something. So we could try to change the source code. So we go back and we'll change the CPP code. Okay. So you can see that this is just a simple script to say hello. So for example, we could just repeat this and it could say hello twice. Just twice. And we save. And now if we try to go and run the command again, the program again, so the CMake hello world, we see that it's just printing out one time. That is because this is the compiled version, so it's not taking into account the changes that you just made. So to do this, you have to recompile. So for this, we do make again. And now even probably we can see the date that we change this file. So we can see the new updated hour of the executable file, which is now. So this file has changed. So now if we go and run CMake hello world, we see that it's written 2 times as we asked it for. So now the thing is that if instead of just editing the files that are already there, but if you create other files, you will not manage it just with make, as we've seen in the theory, because you have to tell the program that you have new files you have to take into consideration. So let's try this. So instead of creating a new file, I will just rename the hello world and to another name. I will call it hello world 2 instead. So now my file, it's called hello world 2. And I probably have to edit the CMake list as well, where here it's saying which files are taking into account. And it says that it's taking into account the file here, hello world.cpp. So if we change this file, we have to update it here on the CMake, list. Or wait, actually, we cannot update it and we can just try to run it again. We can do just make as we did before. And we cannot even do it because indeed it doesn't recognize this file anymore. So indeed we have to tell the program that we just change the file name. So here we call the file hello world2.cpp. We save it, we exit, and then we have to start over again. So we do we go inside the build folder where we were having all the things before, and we do this. CMake again, 2 dots for the previous folder, and we go again and do make. So now even here we can see that indeed it's building the file that we just added, the hello world2.cpp. So if you want to run it again, we can actually check again. So indeed it was changed to the, if this is a new version, and if we just run it again, it just prints the 2 hello worlds like we had already said before to do. So basically, this is it. If you change any file, modify the name or include new files, you always have to adapt it in the CMake list and run CMake. Otherwise, if you just edit one file that's already there, you can just write make and then just run the executable. So it's simply as this. Okay.
I hope you liked it and thank you for watching.